Hello friends, welcome to engineering tutorial. So we will continue our discussion related to scalars and vectors. In the previous video we just had a basic introduction to this concept, the difference between scalars and vectors, and the main point of the previous video was that all physical quantities are divided into two categories: scalars and vectors. Scalars are concerned only with magnitude, whereas vectors are concerned with both magnitude, direction, and laws of vector addition. This was the main idea. Okay. Of the previous video. In this video we are going to discuss about the representation of vectors and some other important points associated with it. Okay. Sorry. So any vector quantity, how is it represented? So any vector quantity is represented by an arrowhead. Okay, this is how we represent a vector quantity. Okay, let's call it this. Here this arrowhead represents the vector v. It is denoted, any vector quantity is denoted by that symbol. Let's say here v is a vector quantity and we place an arrowhead on top of it. Okay, any vector and we place an arrowhead on top of it to denote that it is a vector. This point O, or the starting point, is called as the tail of the vector. The point, the starting point, tail of the vector, and the finishing point, okay, the top of the arrowhead, this point A, is called as the head, or it is also called as tip of the vector. Okay, this is the representation of a vector. So as I said, whenever we represent a vector quantity, we do it by denoting the symbol first, whatever v or whatever any letter, and then we place the arrowhead on top of it. The magnitude of the vector quantity is represented by taking the modulus of this v. We take the modulus and it is just represented as that. Okay, so this is the magnitude of the vector quantity. Okay, so these are some of the basic things associated with vectors. First, it is represented by a simple arrow mark, the arrowhead. The starting point, the point of origination, it is called as the tail of the vector. The finishing point is called as the head or tip of the vector. Any vector quantity is represented by that symbol, whatever symbol we want. For example, for velocity we can use V, for force we can represent F, for displacement we can use D, your choice. But in order to make the others understand that it is a vector quantity, you have to place a vector sign, this arrow sign on top of it. The magnitude of the vector quantity is given by this modulus. Okay. So now we'll discuss another important concept associated with vectors, which is the concept of unit vectors. Okay. So before we discuss unit vector, here it is very important to bring into discussion the concept of coordinate axis, because they will play a very vital role in the representation of vectors. So we know the coordinate system of representation. We can either use the 2-axis system, but generally it is the 3-axis system it comes into play. Okay, because any physical quantity we cannot confine it to one plane. Okay, so we will use the 3-axis system. First, the x-axis, the y-axis, and the z-axis. X, Y, and Z. Okay. Now what is a unit vector? Now most of the time any vector quantity, let's say V, we have a vector quantity which is represented by this V vector. Any vector, it is represented in the form of its unit vector also, magnitude, direction, and unit vector. Now as the name suggests, unit vector, the unit vector of this vector quantity, it will have a magnitude equal to 1. The magnitude of that vector, it will be 1, unit magnitude. That's why it is called as unit vector, and it has the same direction as of this original vector quantity. Okay, the unit vector is represented by V, the same symbol that is used in the original vector, but here it has a cap symbol on top of it. V cap or hat, it is also called as cap or hat, this, like this. Okay, this symbol, it is called as cap or hat. This is the unit vector of V vector. Now what is the formula for unit vector representation? The unit vector is given by V cap is given by that vector and divided by the modulus or magnitude of that vector. Okay, this is the method or the formula of the unit vector representation. Okay, now the unit vector for this 3 coordinate axis, for x axis the unit vector is I, and it is represented as I cap. Okay, I cap. For the y axis it is j cap for y axis, and for z axis it is k cap. The unit vectors in the direction of x, y and z: I cap, j cap and k cap. Okay, suppose I say we have a force equal to let's say 6 I cap Newton. Okay, the force is a vector quantity. Let's say we have a force of 6 I cap Newton. Here this 6 I cap Newton gives us the two important information which is important for a vector quantity. First is 6. It means this has a magnitude of 6 and it is acting along x axis. Okay, this I cap means this force is acting along x axis and it has a value, a magnitude of 6 Newton. A 6 Newton force is acting along the x axis. Suppose we have another force, let's say 8 J Newton. Here the magnitude is 8 Newton and it is acting along y axis. The unit vector only gives us the direction of the vector quantity. This number value gives us the magnitude. Suppose we have another force, let's say minus 4 k cap, whatever the value it is. Here the magnitude of the vector, that vector quantity is 4 because it is the modulus is taken, absolute value, but the direction is in the negative of the z axis, the negative direction of z axis. This minus k cap, it represents that, the negative direction, the opposite direction of the z axis, exactly the opposite direction of z axis. Minus k cap denotes that opposite direction of z axis, and 4 is the magnitude of that vector. Okay, so this is the whole idea behind unit vectors. It has a magnitude equal to 1. It points or directs in the same direction as that of the original vector, and this is the mathematical formula for determining the unit vector of any vector quantity. It is represented by v cap. It is given by v vector modulus, so the modulus of that vector, and we have this 3 system of representation of for denoting the direction of the vector along the 3 coordinate axes x, y and z, which is I cap, j cap and k cap respectively, and this is the whole concept. Okay, so this is all about unit vectors in relation to vector quantity.